All right, part B, we're asked to find the surface area resulting from revolving C about the x-axis. So let's try to get a quick visual of what's going on here. X is between 1 and 8. Y is x to the 2/3. So you can do a first quick and second derivative check. This function is always increasing and always increasing from 1 to 8, and it's always concave down. So it's going to look something like this. So if I revolve this thing about the x-axis, I'm going to get a shape. Looks more or less something like that. And I want to know what the surface area of that is. Okay, so it's kind of a bead-like shape. Well, we have a formula for surface area. Surface area is 2 pi times the integral over the interval we're looking at. We need the radius of the revolution times the arc length, which is the thickness. Okay, so what's the radius of revolution here? Well, if I have a point on the curve, how far is it to the x-axis? That's given by the y-coordinate, and the arc length differential is ds. Okay, so in our case, we have y is x to the 2/3, and we have the arc length differential simplified from part A to be 1/3 x to the minus 1/3 times the quantity 9x to the 2/3 plus 4 to the 1/2 power dx. So I put this all together and I get my surface area is going to be 2 pi over 3. I'll bring the third out front. Whoops. Two pi over 3 times the integral from 1 to 8 x to the 2/3 times x to the minus 1/3 9x to the 2/3 plus 4 to the 1/2 dx, which simplifies to 2 pi over 3 times the integral from 1 to 8. Multiply these together, you get an x to the 1/3 times 9x to the 2/3 plus 4 to the 1/2 dx. So this is the challenge now, is to evaluate that integral, and that'll give us the surface area. Okay, this certainly looks complicated, but we're going to go back to our old rule of thumb. We're going to let u be the thing inside the parentheses. I'm going to get my du, and as before, I'm going to get 6x to the minus 1/3 dx. So when we go to fix things up, things are a little bit different because this is an x to the positive 1/3. I need an x to the negative 1/3. So how am I going to fix that up? I'm going to keep that 2 pi over 3 out here and give me some room. So what do I want? I want 6x to the minus 1/3 dx. Okay, so the 6, I know that I can multiply the inside by 6 and then just multiply the outside by a sixth. But, you know, what's happening with this x to the minus 1/3? It's a variable. I can't divide by x to the negative third outside, so I have to divide by x to the negative 1/3 inside the quantity here, or inside the integral. And if I take 1 over x to the minus 1/3, that's really x to the 1/3. So what I need to do is multiply the integrand by x to the 1/3. So to get this thing ready to integrate, I have, well, let's see, the 2 goes in here. I've got a pi over 9, integral 1 to 8, x to the 2/3 times 9x to the 2/3 plus 4 to the 1/2, 6x to the minus 1/3 dx. All right, so this gives me the du that I want. This is going to be u to the 1/2, which is fine. The question is, what's that? I need everything in terms of u. I go back to my substitution and realize I can solve this for x to the 2/3. So if I look at x to the 2/3 here, is going to be u minus 4 divided by 9. Subtract off the 4 and divide by 9. So I can take that 9 out front, and this is going to be pi over 81 times the integral. And this was the same substitution as I had before. So when x equals 1, u is still 13. And when x equals 8, u is still 40. Now I have the u minus 4 over 9. I brought the 9 out front already. So this is u minus 4, u to the 1/2 du. And when I evaluate this, this will give me the surface area. Okay, so this integral isn't that bad. It's pi over 81 times the integral from 13 to 40. First step is we're going to multiply that through. U times u to the 1/2 is a u to the 3/2 minus 4u to the 1/2 du. I got pi over 81. Use the power rule. U to the 3/2, add 1 to that, you get u to the 5/2. And when you divide by 5/2, you're multiplying by 2/5 minus. Add 1 to this, you get u to the 3/2. Divided by 3/2 gives you 2/3. Multiply that by the 4, you get 8/3. I'm evaluating this from u equals 13 to u equals 40. I get pi over 81 times 2/5, 40 to the 5/2 minus 8/3, 40 to the 3/2 minus pi over 81, 2/5, 13 to the 5/2 minus 8/3 times 13 to the 3/2. Now I'll simplify this as much as possible, but don't get your hopes up. Alright, if you go through all the intermediate algebra, you're going to get 3200 pi radical 10 over 243 minus 494 pi radical 13 over 1215. And remember, this was an area problem, and so we're going to interpret that answer as square units. That'll do it for checkpoint 20.